Hi, so this unit has a problem. I was doing the heating side maintenance, and this unit didn't have any power, and looks like something is short to ground, or maybe open winding on high voltage component, compressor or blower motor or condenser fan motor right there. Okay, let's check. But just looking at the outside, I can definitely say that this motor is burned. Okay, so you can see that the burn marks, and the winding insides are like cooked to black. So I just want to make sure if the compressors are okay. So let's check their winding. So these are contactor for the compressor 1 and 2. Oh, sorry, 1 and 2, and this is for the blower motor. Okay, let's check the continuity test on the windings. Okay, good, good, good. Compressor, good, good, good. Okay, so the compressor windings are okay. Let's check the blower. Open, open, open. So definitely the blower motor is not good. Okay, let's check. There is one more test we can identify that. Let's check the short to ground. So it is gonna be difficult for me to check because I have. Okay, okay, compressor 1, good, good. I'm hoping that I have a good contact with the metal surface. Okay, good, good, good. Oh, on the blower side it's short to ground, so that explains why this unit do not have any power. So maybe the breaker or the fuses are blown. So we will recommend that customer to replace their motor. Once the power is restored and the motor is replaced, then we can further dig out if there is anything wrong with the anything wrong with the condenser fan motor. The windings are, I already checked that the windings were okay. uh, okay, so I have turned off the power, and we'll recommend customer to replace the motor. Once he approved, then we'll come back. Okay, so customer approved the motor. We got new one right there. Okay, let's give it a spin to the old motor. Oh, the bearing sound. Okay, so we're gonna replace it, and this is a dual voltage motor. It's 460 and 230, and here is the schematic for both voltages. So low voltage means 230 volt, and high voltage means 460. So they have given all the how to wire it. So we'll do that. So here they mention here. Okay, so it's a big heavy motor, 7-inch shaft. Okay, so I have mounted the motor on the plate, the same pulley on the shaft, and let's do the wiring. I already figured out. So we're gonna use it for 230 volts. So this is the circuit for the low voltage here. So they have total 12 wire, these wire here, the winding wires. So it says for example, it says P4 to 4. P4 will connect with 4. So here are see, they have marked very well. So if you can see P4 with 4, same P5 with 5, yes, P5 with 5, so like this. And the other three, like 7 to 1, 8 to 2, and 9 to 2, and those three will connect with the line 1, 2, and 3. So P5, 4, 5, 6, they are all connected together, and this will connect to the line voltage. So I'm gonna tape it up and move this thing in the back side, and I will put something here to secure it will not scratch the metal body, and then line 1, line 2, line 3. Once I will do that, I will also make sure the rotation is on the right direction, because this three-phase motor, if I have to switch between the phases to change the rotation, I have to do that. So that's why I'm gonna leave these three out of the hole. Okay, let's fix that. Okay, let's turn on the breaker. On. Okay, so I have turned on the power. I have put the motor back in, connector line 1, 2, 3 wire, and belt is tight, alignment is okay. It's ready for testing. Turn on the breaker, unit is ready for testing. Let's turn on the power here. Let's check the Honeywell economizer board. Yeah, the display is back on. Okay, let's jump into G. Stage 1 compressor. The motor is running. Rotation is good. It's running perfectly. I am going to check the amps. And the compressor 1 is running fine. Suction line is getting cold. Condenser fan is running okay. I'm going to test it to the heat mode. Okay, so that's W1. Venter motor started. Waiting for the ignition. Gas valve is open. Take a while. If that doesn't fire, then I have to dig down for the heating troubleshoot. No. Okay, looks like I have to open up the panel and check what is going on. Okay, so I open up the panel because the heat was not working, unit was not firing, venter motor was working. And when I checked here on the control board W1, it had no power. And from W1 it goes through the safeties, rollout switch, high limit. And I checked here, no 24 volt. So when I check the pressure switch, after running the venter motor, it should close the pressure switch. So there was a 24 voltage at the one end, but on the other side it was open. So I pulled out the cables. So let's jump it out manually. Oh, if you can see, the control board is blinking now, so the circuit is closed. Hopefully unit will fire. So in this case it's a faulty pressure switch, this one. The unit should fire. speed. Okay, we have a good ignition here. Okay, now the blower should turn on. So this is another recommendation we will recommend to the customer to replace the pressure switch or heating side pressure switch. Wait for the blower. Okay. The compressor is also working. So that means it's a older type of thermostat. So older type of thermostat, like a mechanical thermostat, they in that condition, if they are calling for the cool and you jump it out from the terminal on the roof to check the heat, and the compressor will kick in. Okay, that's normal. Okay, so everything is okay, so we have to recommend this pressure switch. So we have successfully turned on this unit and it's working. Thank you for watching.